George Polya was a prolific mathematician whose contributions to the subject were many and varied. He was born in Hungary in 1887 and died in 1985 at the age of 97. He moved to the U.S. in 1940 and held a professorship at Stanford University from 1943 until his retirement in 1953. Polya is perhaps best known for the 1945 book How to Solve It, in which he introduced the now widely used four-step problem-solving process. Written initially in German, the English version of the book was rejected by 4 publishers before Princeton University Press published it. Still in print today, it sold over 1 million copies and has been translated into 17 languages. Polya's four-step problem-solving process can be utilized to solve any problem, problems in mathematics or problems in life. You must first understand the problem, then devise a plan, carry out the plan, and re-examine the solution obtained. It sounds easy enough, but let's look closer at each step. To understand the problem, you basically want to answer 3 questions. What is the unknown? What is given? And how are they related? There are a variety of strategies to tackle this. Read the problem. Reread it. Read it out loud. It's amazing how much reading aloud helps with comprehension. Make sure you know the meaning of all the words used in the problem statement. Try restating the problem in your own words. Identify and label the known or given quantities and the unknown quantities. Use suitable notation for unknowns: x for a horizontal distance, y for a vertical distance, t for time. Draw a diagram, perhaps a rectangle for a rectangular garden, or picture frame, or a circle for a circular corral, or a triangle, if appropriate. You can use a graph, the type of graph in the XY plane, or the type of graph with vertices and edges to model problems. Perhaps a tree diagram can assist with multi-staged experiment problems. A lot of different diagram options exist, so be creative. Consider if a known formula is applicable. The inside front and back covers of textbooks usually have a list of useful formulas. Think about whether you've solved similar problems. Could they be applicable? Traditionally, the hard part of problem solving is devising a plan. This requires previous knowledge, good mental habits, concentration, and resilience. Some common strategies include using a formula, perhaps one you found in the previous step. You could look for a pattern. Mathematics is sometimes called the science of patterns. A systematic list or organized table can sometimes reveal unnoticed patterns. Guess and check is a valid, if inefficient, scientific method. You'll still want to justify your answer. Work backwards, perhaps from the guess and check method. When you already know the answer is an excellent time for practicing problem-solving techniques to aid when you don't know the answer. Consider all possibilities and then eliminate those that lead to contradictions. Sherlock Holmes famously used this strategy. When you have eliminated the impossible, whatever remains, however improbable, must be the solution. Analyze the units. Paying close attention to interrelationships among units of a problem can help you organize the information and may lead directly to a solution. You could make a physical model or act out the problem, or use manipulatives to help visualize the situation. Use note cards, sticky notes, or magnets on a whiteboard like a football coach. These allow you to try many possibilities quickly by moving parts or people. Consider a simpler but related problem. Replace hard problems with easier, less complicated ones. Or write an equation, perhaps using a verbal model to baby step your way to an equation. This is often the preferred strategy in algebra courses. To carry out the plan requires mainly patience and persistence. The plan gives the general outline, and to carry it out requires checking or justifying each step in progression. Essentially, we provide the details by which the solution is revealed. Perform the necessary calculations, plug into the formula, solve the equation. This is the mechanical stage where you just jump in and do the work. Looking back or re-examining the solution is where the power really happens. Once arriving at a solution, resist the urge to circle the answer and move on without further thought. By re-examining your solution and reconsidering the path that led to it, you will consolidate your knowledge and solidify your problem-solving skills. You should ask yourself a variety of questions. Some concern the correctness of your final answer. Have you answered the question? Is the result reasonable? A 45-mile-an-hour stream isn't reasonable, nor is hitting a baseball 3,000 feet, which is over half a mile. Do the units make sense? Did you use all the given information? Other questions pertain to the solution technique. These are particularly critical in developing your problem-solving skills. Can you reuse the result or process for solving some other problem? What if, instead of traveling in opposite directions, the cars were traveling at different speeds in the same direction? What if, instead of a boat traveling upstream and downstream, you had an airplane flying with a headwind or tailwind? Can you derive the result differently? Particularly if your solution was long and convoluted, there might be a slicker, more direct solution. As with developing any skill, becoming a proficient problem solver takes time, patience, and practice. However, problem-solving skills are transferable to all areas of life, school, work, and home, so developing them is well